Well, welcome everybody. So I think we're ready to go. This will be another database and memory office hours session. My name's Andy Rivenes. I'm a product manager for database and memory. We have our landing page there as always. If you're curious about any of our previous sessions, I have them listed here. I don't think there's to get to all of them. I think you have to go through a couple pages, but we've done quite a few. A lot of the features I'll show you or talk about today in the advanced features lab. We've done demos in previous LiveLabs sessions. So if you're curious about diving more into the details of the feature, I encourage you to take a look at those. And then as always, we have our resources, our blog. I've been posting previous sessions with the PowerPoint and a PDF and scripts out on GitHub. So you can click on that link for that documentation. And here's the previous, which is still valid. I'll talk a little bit about that. The first LiveLabs that we had done were for database and memory. And then it's really, this one's a follow-on to that. So I'll talk a little bit about that. So with that, I think we'll go ahead and get started. And we don't need that screen any longer. So let's see, there's a new share. Here we go. So let's go to the PowerPoint and then we'll jump into actually the LiveLab itself. So here we go. And as always, if you have questions afterwards, if you get stuck or if you can feel free to email me, follow me on Twitter, and we'll go ahead and get started. So database and memory advanced features. So like I said, the first LiveLab we had was called Boost Analytics. It went through and showed you how to populate the column store, how to run queries, how to see how much space was used, how hash joins worked, and also how vector group by worked with database and memory, and why queries were so much faster or allowed you to see between the row store and the column store. Was the Boost Analytics. So now we have the advanced features. All of these you can get to on this URL. So the landing page will look like this. I'm going to do the LiveLabs part through PowerPoint because I've actually already created a reservation, which I'll show you how to do. And I've got it set up. This lab, the new advanced features lab, actually uses the first couple of labs in the previous LiveLabs to populate the star schema benchmark and get everything set up. So I've already done that in interest of time. And so what I'm going to do is I'm going to go through slides and pictures, show you what I did to get to where I'm at, and then we'll flip over to the actual LiveLab and I'll kind of walk you through some of the things to look for and to navigation. Well, maybe we'll take a look at one of the labs just so you're ready to go once you go try this on your own, which hopefully you'll do. So anyways, if you hit that URL, you'll hit LiveLabs. And then if you just search for in-memory, so there's a lot of LiveLabs out there, it's just simpler to search for in-memory. And you'll see the database in-memory advanced features one. You click on that. And then you'll see this page. So this will be this is the new lab. It looks a lot like the previous lab and it follows along with the LiveLab standard, if you will. Notice here though, we've got a lot of labs. So I've added all sorts of features beyond just the basics of having database and memory populated objects populated in the column store and using database and memory. And again, you don't have to know all this stuff, but it's kind of nice to know that there's all sorts of enhancements to database and memory that you can use and try out. And we've talked about them, and now I've got it all set up. I guess I should mention one other thing. So we started out, the very first LiveLabs started out in 19C. And then when 21C came out, we upgraded it to 21C. So currently the Boost Analytics lab runs 21C. This lab also runs 21C, so it uses the basic underlying setup with a bunch of additions to it. And then shortly, it's coming up quickly, 23C is already out in the free version and on the cloud. And so we will then upgrade this to 23C as well, so that you can then see how how database memory runs on 23C. And in addition to that, will shows you some of the new 23C features. So more to come, but I'm just kind of wanted to give you a little history of what's going on. So the easiest thing to do is hit the start key. So once you've landed on the advanced features, and this is exactly the same for the Boost Analytics, the first lab as well, you hit the start key. So you have two choices. You can either run on your own tenancy if you have cloud credits and a tenancy already set up, or you can run on LiveLabs Sandbox or their tenancy. So you don't have to pay for anything. This is all free. You don't need to pay to use. Can you cover which advanced features are available in which versions? Sure. Let's see, which advanced. Let me, let's see, what's the easiest way to do that? Maybe I'll just tackle that now. So otherwise, well, actually, let me do that when we get into the lab itself, and I'll walk you through which features. Hopefully, I'll remember I'm going to write it down, and then if I don't, ping me again. And okay. So thanks, Dan. So let's see. Answer live. Let's go back to, if I get my navigation correctly. Can never get the arrows right on this thing. So let me back up. So one question was, what are these? So we have the first, set up the lab environment and enable in-memory populate the IAM column store. Those are the two labs from the previous versions, which sets all this up. And those are 12.102. So then we have in the advanced features, so in-memory expressions, join groups were 12.2. In-memory optimized arithmetic, and I'm pretty sure I've got this right. I have, if you go back to some of my other presentations, you can probably look on both the resources page. We have a little chart, but the in-memory optimized arithmetic was 18C. We supported JSON starting in 12.2, but it was not the JSON data type, which we now support starting in 21C. So we supported JSON, and that leverages, and we've done a couple of AskTOM sessions that talk about JSON, leverages the in-memory expressions framework. And so JSON in, say, varchar2 or CLOBS has been supported with OSON since 12.2, but then we made an enhancement in 21C for the JSON data type that was that came out. In-memory external tables started in 18C, then we made enhancements in 19C and 21C. So we support partitioning. We did, and I walked through that with another AskTOM Office Hours session as well. So they first showed up in 18C, and then in 19C we added some additional external table features, formats to support. And then in 21C, we added partitioning support, all sorts of various partitioning, and we did a demo on that. Full text columns and spatial are both 21C. In-memory high-rate scans is 21C. Automatic in-memory 18C, and then the level high, which is that next one, was 21C. And then in-memory parallel features, we've always supported parallel query, but then we also added in 18C in-memory dynamic scans. So, wow. Okay, so hopefully that catches all of them. So I will continue on. So what I would typically recommend is just running on the LiveLabs sandbox. So I was talking about running on your own tenancy or the LiveLabs sandbox. A database of memory won't run in the free tier because there aren't enough resources allocated. However, on 23C free, it will run because you get all of the options and features, kind of like the previous the free version that we had available prior in 19C. So in 23C, you can actually run it free. And then on your own environment, don't forget the base level feature where we allow you to run up to 16 gigabyte column store without having to license database and memory. We did a couple blogs and AskTOM sessions as well on the base level feature. So if you get nothing else, think if you have questions, go back and look at some of our other LiveLabs, because we've gone through most of the features and changes that have occurred over the life of database and memory, which started in 12.102. So it's been quite a while. So I think we've got everything answered there. I will again try to keep a lookout for that. So once you click on Run on LiveLabs Sandbox, that's what I'll use for my demonstration. The Run on Your Own tenancy will set up pretty much the same. It'll just be on your tenancy rather than on the LiveLabs, Oracle's tenancy, if you will. And you'll get a box that looks like this. The big thing is click that I consent and then submit the reservation. And this morning I panicked a little because right now there's a problem on this page. Typically it'll show how long, it'll do a countdown to when your reservation's available. And that's, I guess there's a problem and that's not showing up. Eventually what happens is it just shows up with launch this workshop. Oops, right here, the launch workshop. So you notice I had run the previous LiveLabs and even the advanced features prior to that. And so then I had kicked this off again. And there, see, the status estimated time remaining, excuse me, wasn't showing up this morning. So apparently there's some error. I went and looked in the support for LiveLabs, and so, but it will show up as a launch workshop once it is actually created. It takes usually 5 to 10 minutes to create the reservation, to get it all set up and where you can launch it. You can go to the, if you pull down on, my name's right there, but your user ID, if you pull down and click on my reservations, you can get this page and it will refresh. But if you're not sure, you can just pull that down again, click on my reservations. And then once it's ready to go, you'll see launch workshop. So if you click on that, that'll get you in and running. So this is just normal LiveLab stuff. Even if you run another workshop, it'll be the same kind of setup. And then once you launch the workshop, you'll get this page here. And so this, you can use this to walk through. This will be in your browser, but and this is all of what you'll see in the LiveLab, which will show up in a no VNC console, if you will. I'll show you that in a second. But the key thing to note is this view login info. If you click on that, then you'll get the reservation information and you'll want to launch the remote desktop. I'll make all these slides available. If the navigation, I sometimes get confused, so you might as well. So if you need a walkthrough, this is an easy walkthrough, I think, with the slides. But once you launch the remote desktop, then you'll get this page here, which is where we're going to pick up on, which I've already done. I did it this morning about, a half hour, 45 minutes ago. And so you'll get basically, notice on the left-hand side, it's the same information as you'll see in your browser. You can actually look at either one. This one will be set up so that you can just run it right alongside. It's much easier to copy and paste within this environment rather than trying to go out into the browser. The copy paste doesn't always work the way this has been architected. So I wind up just running the two side by side, or, since it's all scripts, you can also just type in the script name and run on the browser if it's bigger and the font makes it easier to read. So you can do either one. So let's see, what else do I have here? Okay, so I do go through a few pages, but we're going to do that here. And the lab agenda, so I could have easily just said all these things that show up in what versions. Maybe what I'll do is I'll put a dash next to each of these features and say what version they showed up in. That would be a good thing to do, actually. So anyway, so let's flip over now to the actual LiveLab. So hopefully this, let's get this arranged right so we can see it. Oh, there we go. So here's the lab, that page that I showed you. I have taken the, I'm going to resizing it to make it bigger for me. Hopefully that's good for you guys. But notice that's all the same. It's all of the labs. Same thing you would see in your browser. If you want to look at it there, where you would hit the view login info and launch the workshop. So let me close that down. So it's the same thing. So I went through the initialized environment, and so I'll just show it to you. Oh, one other thing I'm supposed to mention is, notice though that if you get lost, I've created for each of the labs, this one's probably not a good example. Maybe I'll go to the in-memory expressions, I'll come back. A walkthrough that I did of the lab. So if you get stuck anywhere in any of the labs, this is true for the Boost Analytics as well, you can run this video and they sped it up. So there's no talking, it's silent, but it'll go through all of the steps of the lab. So if you get stuck doing something or it doesn't look quite right to you, and I'll make a couple comments about the AIM lab, because based on the fact that AIM is event driven, you can get somewhat different results than what your shows in both the video and the workbook. And so I'll talk a little bit about that in a minute, but you can walk through it if you get lost. So I want to make sure I pointed that out, that there is a walkthrough for each of the labs. So let me go back to the starting again. So in the initialized environment, basically what it's going to do, and if you walk down here and say expand all tasks, that's what I usually do. Initially, when you get the environment set up, there are two CDBs running. And what this does is this goes through and you copy and paste. You can see what's currently running, and make sure you run all of lab 1, which is going to go through and reset up the environment specifically for database and memory. And so will lab 2. So lab 1 gets you a single CDB with the PDB running for database and memory. And then lab 2, and again, there's a walkthrough, we'll go through and set up the column store and change all the parameters so that you get to see everything. Turns on heat map, so ADO will work, and AIM uses underlying the same information for those labs. So basically, the previous lab, it will create the files and the file system. So it does all the things to set up the lab. So make sure you go through, and this is the same as the Boost Analytics lab. So both these two labs are the same either way, and make sure you run through all the steps. So by the end, you'll wind up with the environment all ready to go. And what I did is I came in, oops, no, that's not true. Sorry, too many things going on. I started here, was going through this morning because I didn't want you guys to have to wait and see all of the population. And so I ended up with the everything populated. So it was down. You can go through, I encourage you to do all these, take a look at the attributes. Again, this is the same basics of starting up that we did with the Boost Analytics, but I stopped, I get to it, right here. So we're right at this point in lab 2 with IM populated, and I'm going to flip over the screen, and one of the reasons that you might want to use the browser window is because you might want to make this bigger so that you can see it easily. Just remember that the copy and paste is really only going to work here. So notice you can say copy and it'll copy it to the clipboard, and I'll do that in the next one. And you get then you can just paste it and it just runs the populated script. And notice now that we have everything populated. And just as a reminder, I had changed over the line order table so that it's now partitioned based on year, whereas prior in the 19C lab, it was just one big table. But we do this so that it makes sense for some of the advanced feature labs. And it's typical that a lot of folks will have their larger fact tables will be partitioned. So it makes it a little more realistic. So I have a question. Keep track of time here. Can join groups be created automatically? How to measure influence performance gains of a join group? So join groups can be created automatically by automatic in memory, but that's going to be a 23C feature. So there's a tip that's coming. Currently, you have to create a join group, and I have a lab. And maybe what I'll do is I'll do the join group lab rather than memory expressions lab, just to kind of walk you through some of that. And we did join groups in one of the previous AskTOM sessions in detail. So the question is how to measure the influence or performance gain of a join group. So we go through the lab and show you that. The thing with join groups is that the performance gains, sometimes they're dramatic and sometimes they're not. And it depends a lot because what we're doing is we're making the hash join itself more efficient by making common dictionary elements within the join group, so we don't have to recalculate or re-look up the symbols. And so your mileage may vary in the lab. It's not that dramatic a difference, but remember, we're only working with a fairly small data set. If you have very large tables and you're joining large tables together, then the difference will be more dramatic. And so hopefully that answers both parts of your question. And I'll do the join group lab. So I'll just for, since that'll be a good one. I was going to do in memory expressions, but just because it's the first one that shows up next on the list, but I'll go ahead and jump to that. And so that hopefully gets that question. Dan had another question. If the join group is defined in a relational polygon, will it carry over if the data set is added to the column store? Yes. So join groups will, once you've defined the join group and repopulate the objects, then when data changes, we obviously keep that all in sync and we expand the join group if new dictionary elements are added. So yes, it will be maintained. Hopefully that takes care of that one. And doing this solo, I don't have somebody to help me with the questions. So the navigation, I got to switch back and forth. Yeah, great questions though. So anyways, let me show you one more. Oops, go the right direction. One more. So IM usage would be the last script in this lab. Notice here I had done an LS, and so that's number 9. So the copy and paste, let me demo that just quickly. So here we would just copy the, I'm not sure why that copy's there. It really shouldn't be there. So copy, because you can do either way. You can either, I should mention that. So I've scripted all of the labs. So it's much simpler, I think, just to run the script, whether you want to cut and paste from the OS or do it from the instructions, or you can run, and then I show you the actual SQL that we're running. So you can do that too. I always do it this way. So I run the script. And so then if you go over, I did a copy, and then you right click the mouse and do a paste and then hit enter. And then that's how the lab kind of works. And notice we see that we've got quite a bit of space left over. Join groups will be another in-memory expressions, join groups, in-memory optimized arithmetic. These labs will use additional space to hold the in-memory expressions, which get populated as virtual columns. So in the lab, I will show you the space before and after, but we're not going to do that lab. We'll do the other one, the join group lab. The join groups will add they don't use much extra space. In memory optimized arithmetic will use extra space. So anyways, point is I have enough space allocated here for all of the labs to run, and you can kind of take a look at this. And if you fire this up on your own, you can play around with it. You can't hurt anything. You can always start over again. You're not going to affect anybody else. It's your environment to play with. So you have free reign. So that gets us through the lab 2, which again is the same as the boost analytics. So rather than doing in-memory expressions, let's do the join group. So I'm going to walk you through one of the labs. All these other labs, in-memory optimized arithmetic, JSON, and we demonstrate both the 12.2 version, if you will, of JSON support, and then the 21C version of JSON support. In-memory external tables, full text columns actually uses a different data set, and that lab walks you through populating that. In-memory spatial, that shows you how to create a text, a spatial index on the data. It walks you through that. Quite interesting. In-memory hybrid scans, the ability then, if you decide to exclude columns to save space, but then a query accesses those columns and they're in the selector projection columns, then we can actually go run the query in the column store and go to the row store to pick up the columns. Again, we've done separate both blog posts and office hours sessions, so that I know I'm going through this, but if you want to dive into the details, I would encourage you to go back to those labs or I'm sorry, office hour sessions. So then the lab might make more sense when what you're looking at. So you can use them together. That was kind of the idea. Automatic data optimization, and we'll use just the line order table. And what we'll do there is we'll actually set this up so that the oldest partition will get evicted based on a policy, and then the newest partition will get populated based on another policy. So we'll show you policies, we'll unpopulate and partially populate the line order table and walk you through how you might use automatic data optimization policies to automatically manage the column store or the line order table, in this case, the partitions, based on, say, a rolling window type activity. So you can automatically manage that rather than having to have all of the partitions populated in the column store where you might only be looking at the most current data. And then we go through 2 automatic in-memory labs. And the idea there is to show you, based on usage statistics and the fact that automatic in-memory, once the column store fills up and is under memory pressure, will automatically populate and evict different objects. And I use not the line order table, I use the line order table to fill it up. And then I use different tables, excuse me, which you'll see, to then become hot or cold to show that they can be populated or not populated. And the line order table, when I populated it, I set priority so that it's always in the column store. And so you can control and have just a set of data that's either always in the column store or never in the column store. And then all the rest of the data can be automatically managed, so you don't have to figure out which objects you should populate, which is just a great feature of AIM, especially in 21C. So the AIM level high lab, lab 13, is, I think, quite interesting. And so I would highly encourage you guys to take a look at that. We did that at Cloud World last year in the hands-on lab. And then this year, we're going to do database and memory, another hands-on lab. So if you're going to Vegas for Cloud World or Database World, stop by, register, and you can try it, and I'll show you how all this works as well. So it's up to you how you want to work that. But in the interest of time, let me click on the, I don't forget, the join groups one. And so we're going to do, oops, we have a question there. I'll get to it in a second. Expand all tasks. And I'm going to exit here. And then we'll get started. The question: can you add a few small sentences in the intro which explains what the option does under what can, yeah, sure. Actually, there's a video that talks about it at the beginning. So if you're, now this is the advanced features, and I'd spend more time talking about why you might want to use database and memory in the first lab, which is the base introductory lab. But in the video, we talk about at the beginning of this lab, the risk of confusing people by switching back and forth. If you go back up here to the introduction, we talk about database and memory and what it does and what the benefits are. So hopefully, actually, I already did that. So you might find that useful to go and take a look at this at the beginning. So hopefully that answers that question. So anyways, back to join groups. So let's do this. Expand this again. I find it easier to have it expanded to look at everything. And then to get to the right place, we just do our copy, and it's going to put us over to the join groups lab and log us back into the database. I do the sys SQL Plus. I always like to set it up so that hopefully that we get proper output to view what our scripts are doing. And I'll go ahead and do it this way. So basically what we do is I have an initial query that says, not using any join groups, how does the query run? So kind of comparing performance. And then you just run it. And it's going to take a little bit of time. So it took 5.5 seconds roughly to run our query. And so then what we're going to do, if I go the right direction, is go ahead and create a join group. So question earlier got asked, can this be automated? So the currently no, but that is a 23C feature that's going to be part of AIM, where AIM can not only manage what objects get populated or evicted from the column store, it will also be able to create join groups, increase compression levels, add in-memory optimized arithmetics, all based on usage statistics. So a lot of people don't necessarily leverage some of these advanced features because they either don't, kind of know what the performance impact is going to be, or maybe even haven't even bothered to dive into it because let's face it, I mean, once you enable the column store and populate your objects, you don't want to micromanage it. You want to let the database do its thing. And if you get great performance, everybody's happy. But it is possible to get even better, like in this case, join performance by using join groups. And so currently you have to know the joins. And I've done a blog post and we have some information and documentation. The idea being that for common joins, maybe star schema type queries that you consistently run, or if you have consistent joins that occur as part of your application, then those join keys would be candidates for a join group because you might get a better in performance. So that's kind of what you wind up having to do. So this script is going to go ahead and do that, create the join groups. So copy that, paste this. Okay, it ran a whole bunch of stuff. So let's go back and we'll real quickly review just briefly what it did. So what the query did is, so you can create a join group, but you have to repopulate the object in order to get the join group to be created. So what I've done is the script basically just alters everything to be no in memory, creates the join group, and there you can see the syntax right here. And we're going to actually create 3 join groups on the common join keys in this star schema benchmark that we use, and then we alter the tables to be in memory, and then we query them. And I just do that because remember, part of how we do most of these labs is we have the table fully cached in the buffer cache and then fully cached in the columns or populated in the column store to compare performance. In this case, we're really just comparing the performance of the column store with and without join groups, but so that it doesn't alter any other labs that might depend on having the comparison, we go ahead and do this over again. So right now it's repopulating, and we'll check that in a second. So you notice that we altered the tables, the join groups were created, and whoops, I went the wrong way. We altered them again to be in memory, and then we went to the counts. And so the next step will be to show that things are populated again. So we'll run that query there. We'll see if we're populated. I think I talked long enough that probably will be, and everything's created again. Now, if we go back, so one of the things that I think it talks about I don't think you see much of a size difference, but you might see a little bit of a difference. If we go back up here, notice these are taking about 4. So if you snapshot that or look at that as 478, I don't know that they're much different, but they might be slightly bigger. Yeah, see, they're slightly bigger. Now they're 496. So the join group does take a little bit extra space in the column store. So just fair warning, the IMCUs actually grow because now we're having common values across the IMCUs. So it does take up a little bit of extra space. Nothing in life is free. So now let's move down to, so how do you know that you have join groups? And that's what this one's about. So we can query this and we can see that now what I did, I didn't, oh, did it? It didn't echo. Maybe I should fix that. I don't know if people want to know that. There's a view, user join groups, that you can query or list, and that's how we're querying this data. So notice we've got our 3 join groups. It tells us the tables, and we'll just pick one. For join group 1, it's date, dimension, and line order, the key, and then the global dictionary address, which is not really all that important. But the bottom line is it tells you that you have a join group, which tables and which columns are involved in it. Dan's got another question. It says, to automatically create join groups today, I use DBMS stats to do it and then transfer them over to the DBIM join group. Is this appropriate? I don't think so. I'm not exactly sure what you're doing in DBMS stats, but it's not a statistical thing. So I don't think that will work, but you could, I guess, if you wanted to later send me an email, so I don't know that anybody, I don't think there's anything in DBMS stats that'll do that. And you would have to see the join groups actually created here and then obviously repopulated to take advantage. So I don't think so, but maybe there's something in there that I'm not aware of. I don't think I've ever heard of that before. So if you want to send me the details, then okay, yeah. So I don't think that's going to do it. But I think maybe I misunderstood what you're saying. What you're saying is you use DBMS stats to identify cardinalities, and then based on those columns, you then create the join group. So that's an interesting. It's different than extended statistics. He's putting a bunch of questions in the chat. So that could be an interesting way to understand, if you know, again, knowing that your common join columns and deciding if you have lots of values, then that might be a way to identify whether you get benefit. To be honest, I think just testing it is probably as good, but I'll look at that. Maybe that's worth a blog post to talk about what you're telling me here, Dan. So let me, I'll take a look at that. So I won't finish that up now, but that's an interesting comment, and I'll take a look at that and see what you're talking about, because I don't think we're going to have time for me to try to understand all that right now. All right, where were we? So we looked to see, we did indeed create the join groups, and this is a way for you to tell that the join groups are there. And then, I go try to explain this in the lab documentation here. So that's what all this text is all about, is trying to explain it. So then we run let's use it. So now we're going to run our query again, same exact query, and hopefully, cross our fingers, it's run a little bit faster. Now remember, that's only the first run after we unpopulated, so we might not have gotten. We might have some parse time in there affecting some of that in the query. So you might want to run it more than once. Bottom line is, it looks like it might have been a little bit faster, but what is all this stuff? So the easiest way, visually, to see this use the join group is to then create a SQL Monitor active report, which is what this does. So we ran the query, we got the timing, and then we created a SQL Monitor active report. And if you go to the OS, you'll notice that this part of the script here created this file. So you can go and display that file in SQL Monitor Actor reports, which I'm not going to try to do because I'm not sure whether Firefox will run here. You may want to just cut and paste that into something on your desktop to be able to look at that. But there's another way, which is what I will show you because it's simpler. So I created 2 different ways to do this. The reason you have to do this is because the use of a join group is done at execution time. So it won't show up in the explain plan, if you will, or the execution plan that we normally show you as table access in memory full. It won't show up in the predicate or in the notes. You have to basically look at it, what the execution when it ran and whether it made use of it, and it'll show you that. And I explain that in here. Sorry, let me go down to zip down here. So I show you that here. And again, you can go look at the join group office hours. So if you were to display that join group HTML, you'd see a page that'll kind of like that. You can highlight it. And then if you look on the hourglass for the joins, you can actually see information. There is another way to do it though, which in this case is going to be a little simpler, not quite as visually impressive, but oh, it looks like I have a formatting problem here I'm gonna have to fix. So let me just do it this way. So use join group XML. So the information in SQL Monitor shows up in an XML information, which is what the active report reads. And you can look at that directly by running this query instead. So it's going to run the query. And there's the results and about the same. So we're saving about half a second with this join group. And notice now I've added, so that was the execution plan, but then I've added an additional information that shows you that the join groups were indeed leveraged and in what places in the execution plan they were leveraged. And then I show you the stats. So if we actually go look at that script, oh, it's not going to have to cat it, I guess. I know we're getting a little out of off the beaten path here, but I'll tie this up real quick for you guys. If you look at that, and feel free to do this, notice that as part of this script, if I go the right direction with the mouse, flipping between Windows and my Mac sometimes gets me confused. Notice we ran the query, we selected the execution plan from it. Come on. And then this query here, notice all that gobbledygook that's going through and looking at the XML is what shows you that whether we used it or whether it was observed, leveraged, whether there were encodings, and then I show you the stats. So it's this section of the code or the script right here that then gives you that information. And it's the same basic information, a little slightly different presented that you would see in the monitor report, which I show you, right here. All right, so with the lab, I think the only last part is cleanup. So then we clean it up so that it doesn't affect the other features. Normally you would just leave them, and you could just leave them if you don't need to do this, but I do a cleanup after every lab so that basically the idea is you can run all these labs in any order you want. So you don't have to run them sequentially. They don't build on each other, unlike the some of the labs in the first lab. So if I get out of here and go up one, so these are all the labs, and so you can run once you get the start of it done, the labs 1 and 2, the rest of them 3 through, and let's face it, there's a lot of labs here, 3 through 14 can all be run independently. You could run, if you were just interested in automatic in memory, just run either 12 or 12 and 13 after you've done lab 1 and 2, and you don't have to bother with any of the rest of it. So that was kind of one of the other things I wanted to do, since I added so many labs for the different features that are in database in memory. I wanted to make them so that they would run standalone. And so there's cleanup scripts in each of the previous ones, so that it resets the environment, so that then you can run any other labs that you want to experiment with how it works. All right, so that covers, I think, everything I wanted to cover. And again, you get you can play around with this on your own. It's all there. It's all out there. It's been there for maybe just a couple of weeks. Let me go back now to the presentation, and let's tie things up. So all of these labs are there. Labs 1 and Lab 2, run those. Then any of the rest of the labs, run them at however you want. Then the parallel, so in the parallel one, Lab 14, it's interesting because there I show you not only parallel query, which is important for rack, but I'll just show you in-memory dynamic scans, and they will run in this environment. I put up a little cheat. Normally you have to have a CPU count of at least 24, but we have an underscore parameter in there to allow you to see how that works. So just, food for thought. But and one other thing on the automatic in-memory ones, sometimes when I run them, I get different results than what you see in the lab. It is because they're not deterministic in the sense that they're working based on actual usage. So if you've gone through, and I tried to make them as consistent as possible, but still sometimes if you've queried something or if there's information left over, you'll get slightly different results. It's not a bug, it's not an error, it's just the nature of how automatic in-memory works. And so it's not like some of the other like in-memory expressions where it's all, you either use it or you don't. Automatic in-memory is evaluating the environment and operating on it. So you may see some slightly different results, maybe different compression levels, but it'll do that based on heuristics. And so don't be panicked, but hopefully most of the time you'll see exactly how remember there's a video that walks through how it works. And then obviously the lab book as well, that not only do we show you the queries, but also the results and try to explain what's going on and what you're seeing. So hopefully that's clear. Yeah, and that's kind of what I said here. And anything else? Copy and paste, we went over all that. I remembered to tell you about the videos. And where can you get more information? So always a good resource is the resources page. Whoops. I'm not sure why that did that, but there we go. I could never get it to go backwards, and it just did it for me. But the bottom line is there's links to the AskTOM Office Hours page, to the blog, different blogs, to different information about database and memory, videos. We have on our YouTube videos, we have the GitHub link there. I will post this PDF on the GitHub link for you. And so you can use that as a guide for getting started if you have trouble navigating LiveLabs. And there's other AskTOM sessions I've got out there where I've posted the PDF for the slides to help explain, and scripts as well. And these scripts, obviously, you've got them in LiveLabs. There are, I think these scripts and other scripts are also on the GitHub, the in-memory section of my GitHub repository. So lots of information available to help you, and then blog posts that hopefully explain in more detail and show examples, and then previous AskTOM Office Hours sessions. So I don't see any other questions. We actually had some really good ones, and that's nice to see. And I appreciate all of you joining me. And if there's no other questions, I think I've covered everything that I had wanted to. And to be honest, go out and try it yourself. Again, it's free. All you have to do is set up an Oracle ID. So, I mean, that doesn't cost you anything. And with that, you can run this in the LiveLabs sandbox. You can run many times as you want. It sticks around for quite a few hours, and you can renew the lease to keep it going for a while. They give you pretty much like a day's worth of time to experiment with this, and play around with it. If you have comments, please feel free to email me. I'm more than happy, and I will follow up, Dan, on how to possibly identify candidate columns for join groups, and maybe that'll generate a blog post. Always looking for new material to talk about. And with that, I guess I'll stop and say thank you very much for attending. We should have the next, I'll probably do it in August. We'll do another AskTOM Office Hours. If not August, then maybe September. All that, we'll see how the dates work out, where I'll talk about something we're adding to the in-memory advisor. And so that's a tease. The in-memory advisor, we've added a new it'll show up in the 19.20 RU that talks about how to determine whether a database is even eligible, would even be eligible for database in memory. And then you can dive into that. So it'll be another follow on to some of the in-memory advisor sessions that we've done in the past. So that's your tease for the next office hours session. And with that, I will go ahead and sign off. And again, thank you very much for attending.